Hi, everybody. Good morning. Today is April 8th. So today you have homework 9.3, 9.4, and quiz 5. I haven't graded the quiz 4 yet, so I will grade it. And today we will go over quiz 4 and quiz 5 on Wednesday. Okay? So the remaining month you're going to be very busy. I also want to remind you that for the homework assignments, you can drop the two lowest scores. So, which means if you are very busy and you cannot balance your work, you can miss two homework. Okay, but if you decide to not do that homework, I suggest you to still look at the homework solution and see what types of problems on that homework and make sure you understand those. Also, the quiz, we have 7 quizzes and we also dropped the two lowest scores. So if you're happy with your quiz scores, then you don't have to take some quiz. Okay, we dropped the two lowest scores. And also for the exam, you can use the final exam score to replace the lowest chapter exam scores. So if you have been getting good scores on your exams, so ideally you don't have to take exam 4 if you're happy with your exam scores. But be careful, everybody must take the final. We're not we have 4 chapter exams and 1 final. We're not dropping the lowest. The final exam cannot be dropped. Okay? So it is if your final exam scores is higher than one of the chapter exam scores, then it can replace the lowest chapter exam scores. Is that clear, everybody? Mm-hmm. Okay, so today we're gonna continue on session 9.5. Okay. So 9.5 is the last session of chapter 9. It's about solving trig equations. So if you have an equation involving trig expressions, the first thing you check is how many types of trig functions are there. If there are more than one, so you try to see, can you move all the terms on one side and factor them? If yes, then you can have a lot of mini equations. You can set each factor equal to 0, and then you can solve for the trig functions. If you're not able to do that, then it's better to use some trig identities to reduce the number of trig expressions. And also angles. If the trig equations has the angle, they're not the same angle, you can also use the double angle formula to change the argument, change the angle. So all the angles are the same. Okay, so here are some rules. And after we isolate and we solve for the trig expressions, then you look at the trig graph. So two methods, either use unit circle or use the trig graph. Okay, so I teach you use the trig graph, and your homework, they have some videos teaching you how to use the unit circle to find that. Okay, so here, be familiar with all the shape of the trig graphs. And if the problem asks you to find all the solutions, remember sine, cosine, secant, cosecant. The period is 2 pi. And then for tangent and cotangent, the period is pi. Is that okay, everybody? Mm-hmm. So today we're going to do more examples. So for example, number 4. Look at this trig equations. How many different trig functions are there? 2. You have sine x and cosine x, right, everybody? Here there are 2 different types of trig functions, and we can reduce the number of types because, see, we have the sine square, but you know sine and cosine are related. Yes, everybody? So be familiar with the trig identity. So I give you the chapter 9 formula sheets. So this trig identity, you need to be familiar with that, right? You have been practicing it a lot. And you know sine squared plus cosine squared equals 1. So therefore, for something like this, you can express, so we use the trig identity, sine squared plus cosine squared equals 1. And therefore, the sine squared is 1 minus the cosine square. This is the alternate form of it. We both sides subtract cosine square. Right, everybody? So, yeah, here we want to reduce the types of trig expression. See? We do that. That's why we plug in here. 6. Sine square is 1 minus cosine square. And then continue. We have minus cosine x minus 4 equal to 0. Is that okay, everybody? So we check the types of trig functions and we check the angle. See? The angle. The same angle. Right? Everybody? The same angle, x. If you see 2x and x, you also need to use the double angle formula. Okay? But here, because it's same angle, we don't need to use double angle formula. And then here, we have all the trig functions is just cosine. We can simplify it. So we distribute. 6 times 1 is 6. 6 times cosine square. 6. Yeah. And minus cosine x minus 4 equals 0. So far, so good, everybody? Now we combine the like terms and we order it from the highest power to the lowest power. So we have minus 6 cosine x squared minus cosine x. Okay, what is 6 minus 4? 2. Right, everybody? So this is a quadratic type equation. I like the leading coefficient to be positive. Right, everybody? When you try to factor a trinomial, you want to make the leading coefficient to be positive. So we multiply by -1 on both sides. Then on the left-hand side, what do we have? And then plus. Yes. Yes. The right-hand side is 0 times -1 still 0. Right, everybody? See? If you are familiar with the factoring, you can factor right away with the cosine. Or if you like to make it easier, look easier, you can do a u substitution. You can let u be cosine x. Then this quadratic equation would just look like 6. Cosine x is u, so cosine squared become u squared plus u minus 2 equals 0. Bless you. So you can make it look nicer. It's a quadratic equation. So to find the u, two methods, either factoring or the quadratic formula. Let's practice factoring. Okay? How do you factor? You put 2 pair of parentheses. Yes? And you look at the leading term. What are the factors of 6u squared? Thank you. Factors of 6u squared. 2u or 3u, right, everybody? Or it could be 6u and u. We don't know which one, right? So let's try each combination until we find the one that works. Okay, let's try this. Is that okay, everybody? And then you look at the constant term. What are the factors of -2? 1, -2, or -1, 2. Yeah, everybody? So let's try the first pair. Okay, let's put 1 here and -2 here and see if that works. So we multiply the outside. What do we get? -4u. Multiply the inside. What do we get? 3u. And when we add them, we get -u. Oh, do you see? It's off by a sign. If it's off by a sign, what do? Just change the sign of it. You don't need to switch the 1 and 2. Just change the sign. Is that okay, everybody? About factoring? Because when we change the sign, it becomes -3u and +4u. So when we add them, we get +u, which is the middle term. Yes, everybody? So this is how to factor. Okay. Oh, by the way, I ran out of space. I hope you still have enough space. Okay, let me shrink this. Okay, so I can have more space. All right. Okay, so continue. We have the product of two factors equal to 0. Then we said the first factor is 0 or the second factor is 0. Is that okay, everybody? Mm-hmm. So the product, thank you. The product of two factors is 0. It means either the first factor is 0 or the second factor is 0. Let's solve for u. Okay, what is u? Plus 1 and then, yeah, 1/2. Plus 1 and divided by 2. Right, everybody? Mm-hmm. How about this one? -2/3. Is that okay, everybody? We move the 2 to the other side, become -2, and we divide it by 3. Okay, good. So this is the u. But what is u? Cosine x. So cosine x is 1/2, or cosine x is -2/3. Yes, everybody? So we isolate the trig expressions. Now we want to find the x. This is like inverse trig function. So we need to draw the trig graph. Okay. So like this problem, after we reduce the type of trig expression, then we recognize is a quadratic type equation. So we do a u substitution and we factor. Okay. So finally we can solve for the trig expression. And last step, we need to draw the trig graph and we need to find the x. So you can imagine it's like 4 steps. Okay, now we need to draw the trig graphs. So it's about cosine. What's the cosine graph look like? is a wave and it starts with 1. So we go down and go up. And this is -1. The period is 2 pi. The middle is pi. And the middle is pi over 2. And the middle between pi and 2 pi is 3 pi over 2. Is that okay, everybody? So far, so good? Everybody following? Okay. Now we have the picture. And we want to find all the x. Oh, see this problem? It finds all the solutions from 0 to 2 pi. Okay, so you can expect our final answer. We don't need to add 2k pi. Okay, because it's only asking the solution within the range 0 to 2 pi. Okay, so the first one, 1/2. So 1/2 is right here. It's between 0 and 1. Okay, everybody? So we draw the horizontal line. And now, what is this angle? So how do we know? Yes. Pi, 1/2. The x is pi over, sorry, cosine, right? Cosine, 1/2. The angle is pi over 3. Is that okay, everybody? So this is pi over 3. Okay, now how about this? Do you still have the reference angle worksheet? This one? Yes, everybody? So yeah, for problems in this section, this is very important. Okay, because you want to find all the solutions, not just a single one. So the inverse trig functions only give you one number, and you actually need to look at the graph. Okay, remember our reference angle? Theta is in the first quadrant. Right, everybody? So then, this is the positive number, and this is the negative number, right? And then the negative number will correspond to this angle is pi minus theta. Yes, everybody? And this angle is pi plus theta. And how about this one? Positive number, the x is 2 pi minus theta. Everybody remember the graph now? Look at ours. This guy is pi over 3, which means this length is also pi over 3. Yes, everybody? It's the same reference angle. Therefore, this angle is going to be 2 pi minus pi over 3. Is that okay, everybody? Pi over 3 is in the first quadrant. That's the reference angle. So this point is going to be 2 pi minus the reference angle, which is pi over 3. So we get this number. What is 2 pi? Is like what over 3? 6 pi over 3 and minus pi over 3. The answer is, yes, 5 pi over 3. Okay, so this is corresponds to when the cosine x is 1/2. We get x is pi over 3 or 5 pi over 3. Is that okay, everybody? Yes. See, this problem is not easy because it's a lot. You really need the knowledge we learned before. Okay? So our problem get more and more complicated. Okay, next one. Well, let's look at the cosine x is negative 2/3. Well, negative, it means is going to be down below the x-axis, right? Where's 2/3? We cut into 3 pieces, and then here, this number is negative 2/3. And you draw it. We know, it's going to be this angle and this angle. Yes, everybody? But how do we find these angles? Okay. 1/2 is a common angle values, right? What are the common angle values? 1/2, √2/2, and √3/2, and 1. Right, everybody? Those numbers are the cosine of common angle values. But how about 2/3? It's not any of them. Okay? So in this case, we need to use the inverse trick function. Okay, so look at this picture. We want to find the theta. Well, to find the theta, theta is the reference angle is always in the first quadrant. And the cosine of the reference angle is always positive. Do you agree, everybody? So to find the reference angle theta, the reference angle theta, you will get the cosine theta. It will be positive. It will be positive 2/3. Is that okay, everybody? So even though this number is negative, but the reference angle theta, okay, it will be positive 2/3. So like here, okay. So this is the reference angle theta. And now, so theta is then the arc cosine of 2/3. We learned the inverse trick functions. This is the place we need to use the inverse trick function. Okay? So theta is arc cosine 2/3. Is everybody okay with that? And we know theta will be between 0 and pi/2. Is in the first quadrant. It's an acute angle. After you find theta, look at the what is this? So theta is my graph should be like here. So maybe look at this is better. This is theta. Then this point will be pi minus theta. And this point will be pi plus theta. Do you see that on the graph, everybody? Once you find the theta, then you can find those 2 points. So therefore, this point is pi minus theta, which is pi minus arc cosine 2/3. And then the second point will be pi plus theta, which is pi plus arc cosine of 2/3. That's why when we were learning at session 8.3, I told you don't just use your calculator. You need the trick graph because your calculator it only gives you one answer. It won't give you all the solutions. So look at the trick graph and then you can relate our solution in the reference angle and you get the answer. Now I need your help. What is pi minus arc cosine of 2/3? So 2 point what? Thank you. That's the first number, right? Okay. And how about the second number? Which is pi plus arc cosine 2/3. 9827. Thank you. Or we can put it here, 2.3005 is that number. and this number is 3.9827. So these are all the solutions between 0 and 2 pi. And we finish this problem. Any questions? First step, when you're given a trig equation, you look at the types of trig functions. If you have more than one type, try to reduce it. Okay, use a trig identity to reduce it. And then you look at the angle. Are they the same angle x? Yes, then that's good. And next, you want to move all the terms to the left-hand side and see if you can factor it. Well, in this case, we get a quadratic type equation. So to make it look simpler, we use a u substitution. And then we can factor and find the u, and we express the trig function. Yes, so we can solve for the trig functions. And then to find the x, we need to draw the trig graph and find it. And in this process, you need the reference angle. Is that clear, everybody? Do you have any questions on some specific step? All good? Okay, we're gonna do more example. Wow, we actually spent 20 minutes on one problem. Okay. All right. Number 6. We want to solve for this. Okay. Do you see how many types of trig functions do we have? 2 types, a sine, cosine, right, everybody? Just for this problem, there are 2 different ways. You can express the cosine in terms of sine, or you can express the sine in terms of the cosine. They'll be about the same difficulties. Which way do you prefer? Express the sine in terms of cosine, or express the cosine in terms of cosine to sine? Okay, so we know that, okay, sine squared plus cosine squared is 1. And you want to express cosine squared in terms of sine squared. What is the right-hand side? What's cosine squared? Yeah, 1 minus sine squared. Good. Now we can then plug in. So plug in, we have 2, 1 minus sine squared, and then see, that is the cosine square. Next term, we have 2 sine squared and plus 1. By the way, because the problem in this section is hard, so I hope to do more examples together. Then after class, you're going to work on your homework, a lot of practice on your homework. Is that okay that you don't do the example in class? We do it together? All right. So oh, see? We're going to distribute and combine the like terms. So 2 times 1, 2. And then minus 2 sine squared. Right, everybody? Let's combine the like terms. Yeah. They're both negative. So when you combine them, how many sine squared? Minus 4 sine squared. What's the constant term? 3. Right, everybody? Okay, now we need to solve for the trig expression. How do we do that? So we want to isolate the trig expression, solve for it. Subtract 3. So we get negative 4 sine squared equals negative 3. Yeah, and then divided by negative 4. So -4 cancel. We have sine square is negative cancel 3/4. Right, everybody? Okay, so what is sine theta? When you take square root, you get what? Yeah, plus or minus square root of 3/4. But what is square root of 4? 2. Ooh. Right, everybody? Get plus or minus square root of 3/2. Yes. Okay. This is the sine theta. And we want to find the theta. So therefore, we need to draw the picture of sine. What is the sine graph? It's a wave but start with 0. By the way, when you draw the picture, I hope you can draw it bigger so you can be able to see the angle there. So this is 0, this is pi, this is 2 pi, and this is 1. This is -1. This is pi over 2 and 3 pi over 2. Everybody? Good. Okay. Now, is √3/2 common angle values? Yes. So that's why I say always be familiar with the numbers on the table. So 0, 1/2, √2/2, and √3/3. Sorry, √3/2, and then 1. They're the common angle values. And sine, what angle give you that? Pi over 3. So pi over 3. By the way, you know the middle is pi over 4, right? Yeah, everybody? The middle of the 0 to pi over 2 is pi over 4. And then you cut it into 3 pieces. So when you cut it into 3 pieces, this is pi over 6. That's pi over 3. And you know that sine pi over 3 is √3/2. Is that okay, everybody? This is √3/2. Good. Because then our y, we're looking for when the y value is √3/2. Do you see the reference angle? Is √3/2? Yeah, everybody? And how about this? Yeah, exactly. The reference angle, boom, boom, is pi over 3. Then this angle is pi minus pi over 3. Which is what? 2 pi over 3. That's the positive. And the negative, okay, is kind of the same distance, but negative. Okay? Negative √3/2. And you kind of draw the horizontal line. And then you see we get this angle and this angle. Exactly. Pi plus the reference angle, pi over 3, which is 4 pi over 3. Good. How about this one? 2 pi minus pi over 3, which is, 6 pi minus pi is 5 pi over 3. Yes, everybody? So we get all 4 solutions. The pi over 3, the 2 pi over 3, the 4 pi over 3, and 5 pi over 3. And the first two corresponds to the sine is the positive root 3 over 2. And then the last two solution corresponds to the sine of the angle is negative root 3 over 2. Right, everybody? Look at this problem. Did it say find the solution within the range 0 to 2 pi? No. So we need to find all solution. Okay? So then we say theta pi over 3 nu plus 2k pi. Is everybody okay? Because the period for the cosine is 2 pi. So you add 2k pi, it includes all the solutions. Or the next number is 2 pi over 3 nu plus 2k pi. The next number, 4 pi over 3 plus the 2k pi. And the last one, 5 pi over 3 plus the 2k pi. And these are all the solutions. So they're all the solutions. Is that okay, everybody? Mm-hmm. You still have the reference angle worksheets, right? So keep that in mind. The reference angle worksheet is also on the website. If you lose it, then you can print it out. It's in the next to the 8.3 inverse reference angle worksheets. And we have the sine. See, this is the picture of sine. And then here we have the cosine. And we also have tangent and cotangent, right?
Do we also get this paper for the test?
No, you have to know this paper. Actually, once you draw the picture, you can see it, right? Yeah, this is the theta. Look at this. This point is pi minus theta. And this point, pi plus theta. And this point, 2 pi minus theta. So don't memorize it, understand it. Okay? You know the shape of the sine, the shape of cosine. You draw the lines, then you can see the reference angle and the relations with them. Mm-hmm. Okay, everybody? No, maybe if you miss some class and don't understand this, come to ask me. Okay? Come to ask me. Okay. All right. So this is number 6. Let's continue. Oh, sorry, I forgot to say, if you have secant and cosecant, you know they're related to sine and cosine, right? So you can change it to sine and cosine and use the sine cosine graph. Okay, like this problem. We have secant 3x plus 1 is 7. How do we... So first we check, are there more than one type of the trig expression? No, only one type, the secant, right? How about the angle? Do we have more than one type of angles? No, only the 3x. We only have one type of angles. So good. Now we can solve for the secant. How do we do? Subtract 1. So we get secant 3x is what? 6. Okay, secant 3x is 6. Now we want to find what is the 3x. And if you have secant, what do? Relate it to the cosine, right? So secant is 1 over what? Yeah, secant is 1 over cos. Therefore, the cosine is reciprocal. Reciprocal of 6 is 1 over 6. Is that okay, everybody? Mm-hmm. All right. If the angle is not just x, I would like to put it as a theta. Okay? And then we need the cosine graph. Okay, we need a cosine graph. What is the cosine graph? Waves start with 1. Okay, and this is pi, 2 pi, pi over 2, 3 pi over 2, and negative 1. Okay? Yes. So you use the graph a lot when you get used to it. Okay, so now let's see. Think about this is cosine, bless you, theta. Okay. Okay, so cosine theta is 1 over 6. Is 1 over 6 a common angle value? No. So we need to use the inverse trig function, right? So 1 over 6. Okay, let's say 1 over 6 is here. Then you draw the horizontal line. And then you get this angle. See? This is the angle. And it is theta, right? So here, theta is, because cosine theta is 1 over 6. And because 1 over 6 is positive, so the theta is in the first quadrant, right? So theta is then a cosine of 1 over 6. Yes, everybody? Inverse trig function. Apply a cosine on both sides. Theta is a cosine 1 over 6. Tell me what this is. What this is. This is what? This is, yeah, 2 pi minus theta. So 2 pi minus a cosine of 1 over 6. Okay, everybody? So we have either this angle or that angle. Okay. But be careful. Theta is 3x. Okay? So theta is 3x. You get the two solutions. They're actually about the 3x. So you get 3x is the arc cosine 1 over 6, or the 3x is the 2 pi minus arc cosine 1 over 6. Is that okay, everybody? Oh, yeah. Why don't I just put the 3x? Why do I put a theta here? Because if this is 3x, the graph is not exactly cosine theta. Do you remember when you multiply by 3, this is a horizontal compress? Yeah, everybody? So wait, that's why I don't want to draw the graph of the cosine 3x. Because you need to compress this by a factor of 3. Okay? You can just set this equal to theta. And then you have a cosine theta. After you find the solutions, set your argument, the 3x equals to those two solutions. Is that okay, everybody? Oh, by the way, does this give us a range from 0 to 2 pi? No. So what do you need to add? 2k pi. Yeah, we need to add 2k pi. Yes, everybody? So therefore, x. How do you solve for x? Divided by 3. So therefore you get what? Divided by 3, you get 1/3 a cosine of 1 over 6 plus 2k pi over 3. Yes, everybody? Or it could be the both sides divided by 3. You get 2 pi over 3 minus 1/3 the arc cosine 1 over 6 plus the 2k pi over 3. What does that mean? You know the 2k pi plus over 3, you cannot put this in your calculator, right? Mm-hmm. Just leave it like that. But you can actually use your calculator to compute this previous term. Okay? So 1 over 3 times arc cosine 1 over 6. So I calculated is 0.46778. Okay? And this one, just leave it like that. And then the next number, okay, you see the first two terms, they're constant. You can compute them. And I got 1.62661 and plus 2k pi over 3. So we get, this is all the solutions. Is that clear, everybody? Mm-hmm. Now, when you see secant or cosecant, relate them in terms of, change them in terms of sine, cosine. Then you can use the sine, cosine graph. Okay? All right. Let's see. Okay. Let's look at the next problem. I know only 4 minutes, but I do want to cover as many as possible. Okay, so look at the next problem. Do you see here we have cosine and the sine? They're different trig functions, right, everybody? And look at the angle. Are they the same? No. If they're not the same, we want to make them the same. So here we need to use the double angle formula. So look at your formula sheet. What is sine 2x? Oh, okay. What's your formula sheet? What is sine 2x? Yeah, here, 2 sine A cosine A. So this is 2 sine x cosine x. Plug in. We get 2 cosine x plus sine 2x is 2 sine x cosine x. So make the angles the same. And then, even though we have different trig functions, but can you see there is a common factor? If you're able to factor it, you don't need to have to make all the trig functions be the same trig functions. Okay, what can you factor? The cosine. What's left? 1 plus sine x. See, you get a product of two factors equal to 0. So what do? You said the first factor is 0 or the second factor is 0. You get mini equations. So do you have to change the sign in terms of the cosine? We don't need to, right? Each mini equation, we only have one type of trig functions. And that's good. Okay, everybody? So cosine x is 0, that's already isolated. How about sine x? -1. Okay, good, everybody. So, yeah, cosine. What's cosine graph look like? Wave start with 1. And you're looking for what? Cosine x is 0. 0 right here. Look at this point and this point. What is this point? Pi over 2. What is this point? 3 pi over 2. So x is pi over 2 and 3 pi over 2. So far, so good, everybody? Next, what is sine? What's the sine graph look like? waves start with 0. And that's 2 pi, that's pi. And that's 1, that's -1. You're looking for the sign is -1. Tell me what this angle is. Yeah, 3 pi over 2. So x is 3 pi over 2. Oh, do you see this and this are the same? So that's why the solution is only 2 numbers. And also because the range is only 0 to 2 pi, you don't have to add 2k pi. Okay, good. So yeah, next class, we'll continue with this session. So today you have homework and a quiz due. Okay, have a nice day. Bye.